Hello and welcome. In this lecture we're going to be calculating the number of pages needed to display all the slots we have. Here in the logs you can see that the latest number of pages I had after I was adding lots of pages was 3, and you can see that in my save games I have currently got 24 items selected, so there's 24 saves, and that pretty much checks out. I think if you divide 24 by divide 24 by 3, how many items do we get per page? We get 8, which is less than 9. So also another way of doing that, divide by 9, you can see that we get 2.66 pages. So that does seem to indicate that we should have a total number of 3 whole number pages to show people. Let's dive in and see how this math actually checks out and how we can figure out this maths with the help of Unreal. Let's dive in. So in this lecture, we're going to be calculating the number of pages so that we can actually properly add the number of dots as required. So to remind you, this is where we are in the plan, about midway now. Calculating the number of pages is a bit of a turning point. So how do we plan to do this? So how do pages and slots relate? Say we've got this many slots. I'm not even going to talk about numbers. Let's do it graphically. We've got this many slots that we want to fit into our 9 by 9 pages. Well, quite simply, we are dividing through one at a time, right? We're taking all these slots, popping them into a lot of 9, another lot of 9, another lot of 9, and if they don't fit in the next lot of 9, we just half fill it. So you can think of this as an integer division followed by a remainder, if you like. So we've got an integer division of these blocks ends up with 3 pages plus a remainder of about 5 slots left, which have to go into an extra page. So what does this mean? I mean, you could do a kind of logic to calculate the pages where you have to do an integer division. You get 3 pages, and then you have to add 1 if your remainder is not 0. That's always a possibility, but it's a little bit complicated. A simpler way is just to go ahead and do a floating point division. So that's going to give you, I don't know, 3 point something, and then round up, because if you got 3.0, it won't round up. If you got 3.2, 3.1, it's going to round up to 4, and 4 pages is the right number to give in this case. We should show 4 dots, because even though the last page is half full, it should be represented. So that's how we can calculate the number of pages. But even more interesting is, what variables do we need to know in order to calculate this number of pages? The first thing we need to know is how many slots are in a page. So here we've got 9, but that's a variable number. Where should that information come from? Should probably come from the card grid. And then what's the other information we need to know? We need to know how many slots there are in total, and that we do kind of already know. We know that from the save game. So let's go ahead together and implement a get number of slots for that grid card. The painting grid. So if we look at the painting grid, we're going to need a new public function, which is going to return an int 32 called get number of slots, like so. Now this one should be a fairly simple one to implement because we've just got the information to hand. Let's go over into the C++ and implement it there. And what we're going to do is, basically, we've got ourselves a grid here, and what we want to do is get the children of the grid. So do just a get children count, basically, and that does it. That does the job. You've got how many children have we got of this painting grid, gives us how many slots there are going to be, because the slots are the children of that painting grid. Now, obviously, if you put other children in there, it might get a little bit confused, so do take that into account, that we are making an assumption here. So that is the number of slots. You're going to use that. And while we're here, let's go over to our painting picker, and let's put in a function, just a helper function, basically, private, that allows us to get the number of pages. It's going to be int 32, because the pagination's happening here at the painting picker level. It's going to be an int 32 get number of pages, and I think it can be const. In fact, we could probably make the, which one was it? The painting grid one. that should be const as well. Like so, and that needs to go in the C++2, because it can change the signature entirely. Let's go over to the painting picker.h. We've got our get number of pages, which I now need to translate over into the C++, so let's copy it across. I'll stick it at the bottom here. And get number of pages is currently unimplemented, but what I do want to do is show you how we're going to just use it in the begin play at the moment, where we're just going to log it out, and eventually we're going to use it to spawn the right number of things, but not just yet. So the number of pages, that's what I'm going to be logging out. It's going to be %d, it's an integer, and it's going to be get number of pages. Or call to that. Okay, so I'm going to go ahead and build that. Okay, let's turn this into a challenge for you to implement the get number of pages. So we're going to use IntelliSense or browse the source code to find the fmath library functions we need to do the rounding up. You're going to need to figure out how to avoid integer division, because we've got currently two integers, the number of slots in total and the number of slots per page. Those are two integers. You need to find a way of getting two integers and turning them into a floating point division. How do you do that? And you're going to have to test the page number that we get at the end. So pause the video and go ahead and implement this. Okay, so let's get started. So the first thing to do, what should it be? Calculate the number of slots. Yep, I think we can do that first. So I'm going to call it int32 total number of slots. And that's going to be from the paintings in the save game. If you do a save game load get slot names, then that's an array. And if we do .num on that, then we can get the number of slots there. So int32 then for the next thing is going to be slots per page. And that is going to be from our grid widget. So if we go ahead and get our grid widget from here, like so. And in fact, this is getting a bit tiresome having to repeat this bit. In fact, I think we've repeated it 3 times or more by this point. So let's just create a little helper function. So what is it? It's get user widget object with getting the painting grid, basically. And let's just call it get painting grid, I think. It'll be private. Get painting grid. What's the return type? Let's see, what is the return type uPainting grid? Obviously that's going to be a pointer, and this is going to be const. And I'm just going to implement it in line if possible. Should be fairly straightforward to implement in line. So let's do that. I'm just going to cut it out there. Paste it in instead of this return statement. Like so. Okay, so we've got the get painting grid. Should work effectively. And now we can just replace usages of it with get painting grid, which should be nice and straightforward. Just like that. Everywhere where we had it, we can change it. Like so. Makes it a little bit tighter down here as well. We want to do that. We do want to do the null check still, because we don't want to be trying to dereference something that's null. But we do not necessarily need all the repetition. So get painting grid arrow, and then we're going to get what did we call that function? Get number of slots. Like so. And now we just need to do that calculation. How do we do this final calculation? Well, if you'd searched around, you'll have found that to get a floating point division, you have to cast one of the two to a float. So it's going to be a total number of slots divided by slots per page, like so. And this just basically is going to work out as a floating point division, because this cast here, the C-style cast, has turned float number of slots into a float. Then what we have to do is we have to round this up. So we're going to have to do an F math : and then ceil is the name of what we're trying to do. Trying to round up is called ceil because it stands for ceiling. We're trying to go to the ceiling. And so don't worry if you struggle to find that. And then you can choose the type that you want to have come out of it. It could be a double, a float, or an int. We're going to want an int to come out of this. And like so. Should pretty much do the trick for us. The last thing I'm going to do is, there's a widget I managed to forget to replace. Let's replace that one too. Last thing I'm going to do is actually move this log message into the refresh slots because of the wonderful things he does. No, because I want that to happen every time we add a new page so that we can more easily and readily debug this. Okay, so let's rebuild and see whether we are getting the right number of pages in the logs. Okay, apparently I've got an error in here, and I believe that it's probably an include error. It's giving me very unhelpful errors down there. So let's see, it's the paint and grid I think I need to include in the header file. So let's go ahead and do that. Rebuild, see if that works instead. Okay, one more build error now seems to be here on this line, and it's basically saying, don't know what you're returning when you return basically empty out of an int32. It should return something. So let's say that we return 0 pages when we don't have a paint and grid. I mean, hopefully that should never happen, but you just have to make sure that the type system is happy. So finally that compiles. Let's go over into Unreal, hit play, and let's bring up the log in the background. Number of pages is 1 at the moment. That's a good sign, I think. Now let's go and add in some slots rather. So 1, 1, 1, 1, 1, 1, 1 page, still all 1 page with 9 slots. And you notice something weird is happening here at the bottom, but never mind. And then let's add one more, 2 pages, yay! And if I keep adding 2 pages 9 times, it should then go up to 3 pages. So that seems to be doing the right thing. I'm happy that our maths checks out, and we can go on to the next video where we're actually going to add the right number of dots according to whether or not, well, the number of pages that we have. So if we've got 1 page, we'll have 1 dot, 2 pages, etc. You understand the general principle. So why is that going to be interesting? Because we're going to have to refactor our pagination system, our refresh system rather, to include the refreshing of dots. So see me in that video for how to do that.